For our final lecture of this first week, we will see how to actually use Python on our system. So Python is a programming language which is available on all platforms. So whether you're working on Linux or on a Mac or on Windows, you'll be able to find a version of Python that works on your system. Now, one of the small complications with Python is that there are two flavors or two versions of Python which are commonly found. So there is an older version called Python 2.7 and there is a newer version called Python 3, and Python 3 is the one that is being actively developed. Python 2.7 is more or less a static version, and currently Python 3 has the version 3.5.2 or something like that. So there's not much difference whether you're using 3.5 or 3.4, but there are differences between 2.7 and 3. And for the purpose of this course, we will work with Python 3. So what is the difference between these two versions? Well, Python began with a few features and it kept developing into a more uh, versatile programming language. So Python went through many iterations, and Python 2.7 was a version that was reached when the developers of Python decided that they should kind of make a clean start, and some of the new features which had been added in a kind of ad hoc way onto the language should be integrated in a better way, which makes it a more robust programming language. So Python 3 essentially is a modern version of Python which incorporates features that were added on to Python as it grew in a way that makes it more consistent and more easy to use. But as often happens, a lot of people had already been using Python, and Python 2.7 has a lot of software written using that version. In particular, a lot of software that people find convenient to use, such as scientific and statistical libraries of functions where they don't have to use it themselves but just invoke these libraries, are still written using Python 2.7. And if you run it from Python 3, sometimes these functions don't work as they are expected. So this has forced Python 2.7 to live on. Eventually, we hope that somebody will take the effort to move Python 2.7 libraries to Python 3, and of course newer code is largely being developed in Python 3. But you should remember that when somebody says they are using Python, they could be talking about 2.7 and not 3, and you have to make adjustments. For the purpose of the introductory material that we will be doing in the course, there is almost no change between Python 3 and Python 2.7. However, there are some features that we will see which are slightly different in 2.7, and we will explore them in 3, and I will try to highlight these differences as we go along. But going forward, since Python 3 is the current version, and it has been the current version for some years now, at least for 4 or 5 years, it's definitely the language which is going to dominate in the future. So it's better that you start with the new version than go back to the old version. So as far as this course is concerned, any version of Python 3 should be fine. The latest version, as I said, is some 3.5.x, where I think x is 2. But if you don't have 3.5 but you have 3.4 or 3.3, don't bother, everything should work fine. But if you are interested, you can install the latest version. If you are using Linux, it should normally be there by default because many Linux utilities require Python, and so Python should be on your system, but it could be that the utilities use Python 2.7, so make sure that you install Python 3. You can use the package manager to do this. Now, if you're using a Mac or you're using Windows, then Python may or may not be installed, especially Python 3 may not be installed on your system. So there is a URL given here. If you search on Google, you will find it. Just search for Python 3.5 install or download and you will get to this URL. So www.python.org downloads release Python 350. So 350 is really referring to 3.5.0. So actually the current version, as I said, is not 3.5.0 but 3.5.2. So you will find instructions there. Please download the version that is appropriate for your system and install it. These are designed to be fairly self-explanatory install files. If you have a problem, please search online for help with the problem you are facing or ask someone around you. It is not the purpose of this course to spend a lot of time telling you how to install software. So I hope you are able to do this so that we can get ahead with the actual programming part. So one more thing to keep in mind if you are familiar with other programming languages is the distinction between interpreters and compilers. So the main difficulty is that programming languages like Python or C or C++ or Java are written for us to understand and write instructions in. So these are somewhat high level instructions. On the other hand, computers need low level instructions. So when we talk about names and values like I, J, or we talk about lists, the underlying computer may not be able to directly analyze these things. So we need a translation. If you remember the very first lecture, we talked about arranging chairs. So we said arrange the chairs as a high level thing, and we said put 80 chairs in 8 rows, 10 each, right? So we said that there could be a difference in the level of detail in which you give instructions, and this is precisely what happens. Okay, in order to execute something, a so-called executable file that we come across is something which is written at a level that the machine can understand. Whereas the programs that we are going to explore in this course and which all programmers normally work with are at a higher level which cannot be directly understood by the computer. So we have to bridge this gap somehow. So a compiler is a program which takes a high level programming language and translates programs in that language to a machine level programming language. So it takes a high level program in Python, not in Python, in C or C++ or Java or something and produces something which directly a machine can execute. On the other hand, the other way of dealing with a high level language is to interpret it. So an interpreter in normal English is somebody who stands between people talking different languages and translates back and forth. So an interpreter is a program which you interact with and you feed the interpreter instructions in your language, in this case Python, and the interpreter internally figures out how to run them on the underlying machine. So whether you're running it on Windows or Mac or Linux, the interpreter guarantees that the answer that you see at the high level looks approximately the same independent of the actual platform on which you're running it. So Python is by and large an interpreted language and we should be aware of this fact. So we use Python typically in the following way. We first run the interpreter. So remember the interpreter is a program. So we first invoke the interpreter and when the interpreter is running, we pass Python commands to the interpreter to be executed. The nice thing about dealing with an interpreter is that you can play with it like you play with a calculator. You can feed it commands and see what it does. So it's very interactive. Of course, it is tedious if you have to type in large programs. So there is a way to load a program which has been written already using a standard text editor and loading it from a file. So what I've shown below in green is, so this is what we will see in a minute, is the prompt that the interpreter shows you. So when you enter the interpreter, it will ask you to execute a command. And this is a command that you provide the interpreter. It says, so I have stored, so I have a file called, say, file name.py typically, okay, to indicate it's a Python program. From that file, import all the definitions and functions and code that's written there, right? So this will tell the interpreter to take everything that's written in that code and put it into its current environment so that those functions can be used. So these things will become a little clearer in the demo that I'm just going to show you. And then you can play around with this. And in the next week, we will get into the real details about exactly what goes into a Python program. So here is a window showing a terminal, which on Windows would be like a command prompt. I'm using a Unix-like shell. So if I say ls, it shows me the list of files in my current area. And all these files with extension .py are actually Python programs. In this, I invoke the Python interpreter by saying Python 3.5 because that's the version which I'm using. If I invoke it, it will produce some messages telling me what type of function system I'm on. So it tells me that I'm using, for instance, 3.5.2, and it tells me that it's a fairly recent version. It tells me it's on an Apple and blah, blah, blah. But what is important is it then produces a prompt, a place where I can enter commands. And this is signified by these 3 greater thans. So now at the Python interpreter prompt, you can directly start writing things. So for example, you can say I is equal to 5. Okay. What this says is that take a name I, assign the value of 5. Now if I type I, it tells me that the value is 5. Okay. If I type an expression like I plus 1, it tells me that it's 6. So you can use it as a calculator. Okay. So you can do simple arithmetic if you want. Okay. So you can keep interacting with it. Now you can also define functions. Remember how we defined a function? We use def, use a function name and so on. So we can say, for example, def twice x. So this is a function twice, which takes a single argument x. Okay? And as you might expect, I would like to return 2 times x. Now, Python uses, as we mentioned in one of the earlier lectures, indentation in order to specify that something is a part of something else. So the definition consists of a bunch of steps. So I must tell it that these bunch of steps belong to this definition by indenting it. It doesn't matter how you indent it as long as you use the same indentation uniformly. So if you're using 2 spaces, use 2 spaces. If you're using a tab, use a tab. But don't mix up the number of spaces and don't mix up tabs and spaces because this gets you confused the error messages from Python. So let's use 2 spaces. So let us just, for the sake of illustration, create a new name y and say y is 2 times x. Okay. Now it's still continuing to ask me for the definition, so the prompt has changed to dot dot dot. Now I must indent it the same way and say return y. Okay. So what I've done is this function takes a value x, computes 2 times x and stores it in the name y and returns the value of the name y. Right. So now when I'm done with this, I give a blank line and this function is now defined. Right. So now twice 7 makes sense. Okay, or twice 932 will also make sense. Right? So Python is very convenient in that you can actually define functions as you go along on the fly. Now we could also define our GCD right here, but as you might expect, sometimes a function is too complicated to type in without making a mistake. And secondly, you might want to play around with the function and change it and not have to keep typing it again and again. So for this, what we need to do is first type the function into a file and then load the file here. So let us get out of this. So one way to get out of this is to type quit with brackets and then you get back to this prompt, which is $, which is the outside terminal or the command prompt. So I have actually already created something. So let us start with, so I use an editor called Emacs. You can use any text editor. If you're using Windows, you can use Notepad. If you're using Linux, you can use Emacs or VI, or you can use some simpler editor like gedit or Kate. Anything that is comfortable, but it should just be a text editor. It should not do any formatting. Don't use word processors like Office or something like that. Use something which just manipulates text files. So if I look at gcd1.py, so one nice thing about Emacs is it shows me colors to indicate certain things. So def, this is the very first GCD program we wrote, which takes computes the list fm, then the list fn, then the list cf, and then it returns the last element in cf. So this is the first version of GCD. So this is exactly the code we wrote before. The point to remember is that I have made sure that all these indentations are at the same number of spaces in. Okay, so this is something to remember. So now you type in something like this, right? Then you save it and exit. Now you go back to your Python and you save from that file gcd1 import star. What this means is take the file gcd1.py and load all the functions which are defined there and make them available to me here. So now if I say gcd of 7, let us have an example 14 and 63 for instance, it tells me that GCD is 7. Okay. Now if you take some large number like 9999 and 1000, okay, then it takes, okay, so maybe one more digit, let us see. Okay, you will notice that it's not giving me an answer, and then it gives me an answer. So this is just to illustrate that this was a slow GCD, right? So it took, so remember, see how much time it took, right? There's a visible gap of a few seconds before it produces the answer. And this is an illustration that this is not a very efficient GCD. So one of the problems with this Python interpreter, which I will see if we can solve, is that if I have already loaded one file, then it's safer to exit and then reload another file rather than to update the file. So let me reload. For instance, the last version of Euclid's thing, which we wrote, which is the remainder version, it says that if m is less than n, exchange the values. If then the second line here says that if the remainder of m divided by n is 0, that is n is a divisor of m, then return n. Otherwise, replace the GCD call by the call to n and its remainder. Okay. So this, we also had a version of this where we did it with a while loop. So let's use the while version. So the while version says that so long as the remainder is not 0, we keep updating m and n to n and the remainder, and then finally we return the value of n. So I'm going to take this particular thing and load it into Python. So again, I first invoke the interpreter Python, and then I say from GCD Euclid to A import star. Yeah, now I'm going to give that same large value that we saw before, which I think was say 7 nines and this, and now you see you get an instant answer. Okay, so in fact you will see that if I give it several more digits, it should hopefully work fast, right? So there is a dramatic improvement in speed which is even visible in this simple example if we replace a naive idea by a clever idea. So the power of algorithms is to actually make a program which would otherwise be hopelessly slow work at a speed which is acceptable to you. So do load Python on your system, invoke the Python interpreter, and play around with the code that we have seen in this particular week's thing. Make errors, see what Python tells you when you import a file which has errors. For instance, now if I try to invoke a function which doesn't exist, like if I use a function which I have not defined and which Python doesn't understand, then it will give me a mistake like this. It will say bloop is not defined. Okay. If I write something strange like 7 less than greater than 5, okay, then it will say that this is invalid syntax. So the interpreter will look for expressions. If the expressions don't make sense, then it's going to complain. And sometimes the error messages are easy to understand, sometimes they're less easy to understand. As we go along, we will look into this. But the purpose of the interpreter is to either execute what you have given it or tell you that what you have written is somehow not executable and explain why. So do play around with it and get some familiarity, because this is what going to be our bread and butter as we go along. So we are going to be looking at some specific features of Python in this course. But you may find as we go along that there's something that you don't understand or something new that you would like to try out on your own. So it's always a good idea to have access to other resources. The Python online documentation is actually an excellent place to look for details about Python, and in particular there's a very readable tutorial. Especially if you already have some familiarity with programming, the Python tutorial is probably the best place to start learning Python for yourself. So here is a URL, docs.python.org/3. This is for Python 3. Tutorial index.html. If you just go to docs.python.org/3, you will find there are also more detailed reference manuals and so on which you might need at a later stage. So do keep this as one of the places that you look when you have difficulties. And there are 2 books which are probably useful to understand Python beyond what is covered in the lectures if you feel that something is not clear. So there's this book called Dive into Python, which is adapted for Python 3. And there is a book called Think Python, which is about generally about computational thinking in the context of Python. Both of these have the nice advantage that they are available online, so you don't have to buy anything. You can just browse them through your browser on the net. So before we leave you for this week, remember that learning programming is an activity. Okay, you cannot learn programming theoretically. You have to write and execute code to appreciate the subject. You have to make mistakes, learn from your mistakes, figure out what works, what doesn't work, and only then will you get a true appreciation for programming. The reason we are going with Python is because Python has a very simple syntax compared to other programming languages. We have already, without formally learning Python, seen some fairly sophisticated programs for GCD, and hopefully you have understood them even if you cannot generate them. So it is not very difficult to explain what a Python program is doing with a little bit of understanding. So do take the time to practice the examples that we have seen this time. We will be giving programming exercises as we go along. And unless you do these exercises and become somewhat handy at manipulating Python yourself, you will never truly learn both programming and Python. The other thing to remember is that once you have learned one language, even though the features and the syntax vary from language to language, it is very easy to pick up another language because all of programming has at its base very similar principles. So, although the syntax may vary, the ideas don't, and the ideas are eventually what drive the program. But to be a fluent speaker of a programming language, you must practice it. So, do try.